Hello, welcome back. This is Vasudev, Product Planner for Power Solutions, the Tectonics Oscilloscope product line. Today we are going to talk about the new solution we have introduced, the digital power management solution for enabling power rail designs. A typical power rail circuitry would look something like this, which has multiple power rails to be verified, tested, validated and designed. Digital power management or power integrity is simply an assurance that the power applied is appropriate. It's not just keeping voltages within the limits, but you have to look at the ripple values, the interference that's happening from the high-speed serial space, the impedance measurement. So here is a quick insight as to what the measurements look like. Depending on the area of interest or the amount of ripple you are measuring, you can use an MSO 6 series 4-channel scope or an MSO 5 8-channel scope to look at multiple rail capabilities. Once you have the acquisition engine in the form of an oscilloscope, you need a good power rail probe. We have introduced the TPR series power rail probes which can handle plus or minus 60 volt offset. On top of it, you need an automated power rail measurement solution, and that's where the third solution component comes into play, the automated power rail testing software which runs on the 5 and 6 series MSO oscilloscopes. So all in all, not only use this solution for your power rail testing, the same setup is used for your frequency response analysis like the two-port impedance measurement, which is important. Here we are looking at a multi-rail power rail DUT from Texas Instruments, and the next few minutes you will see how the connections are made and how we can look at performing the power rail measurements. We have used this TI demo board which has got multiple power rails and connected to two power rail probes, in this case TPR 4000. So this is a good example of how multi-rail testing can be done simultaneously using an multi-channel scope like the MSO 58. The demo board is powered by the Ketley power supply, which can also be fed through an USB port if the DUT demo board mandates it. So here you see the oscilloscope analyzing at least two power rails at this point of time, and we'll see how the software enables multiple power rail testing. The power rails are automatically identified by the oscilloscope on channel 1 and channel 2, and here we have got the digital power management software. On an MS458 you can perform 7 power rail testing simultaneously. In this case we have added 2 power rails. We can go into the configure, ensure that the power rail auto set automatically makes the vertical horizontal scale and the record length, and with the spectrum view auto set you also now get the spectrum view. This is a very powerful capability wherein you are not only seeing the analog waveforms but also the spectrum view as good as what you see in a spectrum analyzer. In the configure menu you can select the ripple frequency of interest. Basically you know as designers which particular component of the frequency is causing the ripple, so you can enter that, and the span of the spectrum view can now be adjusted to ensure that the spectrum views are automatically aligned appropriately. What we have done here is we know that there is a ripple happening at 964 kilohertz. We have entered that, and you can also now look at ripple on ripple. So as you see here, we have zoomed onto the signal and then looking at not just the ripple frequency of 964 kilohertz but a 1.9 kilohertz ripple on ripple, 1.9 megahertz ripple on ripple capability. So simultaneously you are looking at a ripple frequency at 964 kilohertz, and on the same signal at 1.9 megahertz you are looking at ripple on ripple. So you can now simultaneously look at multiple rails, up to 7 rails at the same time, look at the spectrum view to identify the source of ripple and noise and ensure that the whole design verification validation is done simultaneously on 7 rails. You can also add overshoot or undershoot, and here we enable you to enter the reference voltage values of each of those power rail signals So once the software gets these reference voltage values, it looks at the overshoot and undershoot. So as you can see here, we are performing simultaneously ripple measurement, overshoot, undershoot measurement in one go on not just one rail but up to 7 rails simultaneously. This is a huge value add to the power rail designers who are finding it extremely time consuming to perform power rail design verification and testing on each rail at a time. Here, the Tektronix solution enables you to perform up to 7 power rail testing in one go on an MSO 58 oscilloscope. You can now also add a results table so that you can see what's happening on each of the 7 rails. In this case, the demo is on 2 rails, and then you can capture all of this in the form of a MHT or PDF report format, so that you capture not just the analog waveforms or the ripple components but the ripple on ripple and get it into a very comprehensive reporting capability. So this gives you a very powerful insight on enabling multi-rail testing at the same time. That is up to 7 in case of MSO 58. If you want very low ripple frequency, the MSO 64 is a good fit. But add to that the one box solution capability for not only traditional power rail testing but also the 2-port impedance measurement. For any further details, please contact me, Vasudev, or my colleague Gajendra Patro. Thank you very much.